I think you're ready. So, true. What do you think? There are 9 planets in the solar system. True? Not true. Not true. Yeah, not true. I think there are 8. Pluto is not a character. Pluto is not a character. Pluto is a Disney character. It's the same time everywhere in the universe. True? Not true. Not true. China has the biggest population. True? Not true. Belgrade is the capital of Yugoslavia. True? Not true. Not true. I'll come to you. And the continents are fixed. True? Not true. Okay. So more things. Homosexuality is a crime. The prime minister is always a man. Smoking is good for you. Japanese people have a longer intestine. A low-fat diet is good for you. What do you think? True, false? Yes, I've told you so. What do you think? Homosexuality is a crime. True, false? The prime minister is always a man. True, false? Smoking is good for you. True, false? False. Japanese people have a longer intestine. True, false? And a low-fat diet is good for you. True, false? Yeah. I think most of these things. I think all of these things. I think are not true. Now, just a quick question. So how many planets are there in the solar system? Which country has the biggest population? And what happened to Yugoslavia? Please discuss. Please talk to each other. How many planets are there in the solar system? 8. Yeah, there are now 8. And which country has the biggest population? India. So yeah, recently India now has more population than China. What happened to Yugoslavia?
It was it's separatist because serious war happened.
Yeah. So it's now yes. There's no more Yugoslavia. Another. So here are some more things about. Here are some more things that maybe these are true. Maybe these are not true. So monkeys and humans have a common ancestor. Is this true? And how sure are you that this is true? The climate is changing because of human action. Is this true? How sure are you? The sun will come up tomorrow. How sure are you that the sun will come up tomorrow? And smoking is not good for you. Smoking causes cancer. Are you sure? How sure? Can you try? So try and put a percentage. And the Earth is round. Please talk about these things. What is your level of certainty from 0 to 100? Monkeys and humans, common ancestor. How sure are you?
I think 100%.
100%. Okay. Wonderful. Excellent. The climate's changing because of human actions. How sure are you? 80%. Okay. The sun will come up tomorrow.
100%.
Okay. And smoking causes cancer.
So 20% higher or something. So
20?
Oh no,
Only 20?
80%.
80%. Okay. And the Earth is round. 100%. Okay. Yeah. So yeah. Good. So here's a picture of the Earth not being round. This is a flat Earth model. How do you know you're 100% sure the Earth is round? How do you know? Could you please talk to each other? How do you know? Do you think the Earth is round? Yes. Yes. I think maybe everyone. Maybe you all think. Well, how do you know? How do you know this? Yes. What is your evidence? What is your proof? Any ideas? Oh, somebody told you, and you believe them
Yes,
without any hesitation. Wonderful. Maybe that's wonderful. Oh, anyway, yes, yes. How do you know, Mr. Schroeder?
We saw many pictures.
You see many pictures, right? Okay, wonderful. Yes, which you trust.
I can't prove it.
You can't prove it. Okay, okay. How do you know the Earth is round? Is the Earth round?
Yes, I think so.
Why do you think so?
You were just taught that way.
You're taught. Okay. So if somebody had taught you that the Earth was flat, you would believe that the Earth was flat. Yeah. If your teachers had said the Earth is flat, you would believe them. If they showed you pictures, here are some pictures. Look, here's a picture. Here's a picture. This is a picture. Yes. There is. I know the Earth is round. I have two bits of evidence. I have three bits of evidence. One of them is I've seen an eclipse, a lunar eclipse. And a lunar eclipse is when the Earth is between the sun and the moon. And on the moon, I've seen the shadow of the Earth, and it's round. So not just a picture. I've seen pictures. And I trust the people who took the pictures in their spaceships. Another piece of evidence: if I've been to the sea. And when you see a ship coming over the horizon, the first thing, if it's a sailing ship, the first thing you see is the sails. So you see the top of the ship is coming this way. And you can see, if you're at sea, you can see that the Earth is round. And another bit of evidence is that I've been around the world. I've been from England to Japan, from Japan to America, and America back to England. And I had to change my watch because I arrived one day different. So I have, and I've done that. I've actually done that twice. So I know. So I have. That's some evidence, some direct evidence that I have. But of course, there are different ways that we know things, One thing is experience. We know things from our own life. One thing is authority. So when your teachers tell you something, then or the government tells you something, or people in authority, or your parents tell you something, you believe what they say because you trust people. Reason, we can use logic and our minds and our brains. Another reason is belief. So there are some things that we believe to be true, and that's also, and all of these, none of these is wrong. None of these are right, but we need to be aware. Why do we believe stuff? Why do we think stuff? How do we know stuff? And this is kind of the basis of science. Which one would you trust most? Do you trust experience or authority or reason or belief? Because sometimes my teachers taught me that China had the biggest population. My teachers taught me that Yugoslavia is a country. And now I find my teachers were wrong. And sometimes you find the authority is saying one message, but your experience maybe tells you a different message. So, which do you think? Which of these four things? Please discuss. Please discuss. Which do you trust more? Sorry, this is a difficult question. This is a difficult question, and it probably depends what we're talking about. Some things maybe belief is maybe more important. Sometimes maybe reason. Sometimes authority. So these things. When I was born in 1967, which I think is a long time ago. It used to be not a long time ago. I think now it seems like quite a long time ago. And in 1967, there were 9 planets in the solar system. And also, there were no planets outside the solar system. So when I was born, the only planets were the 9 planets in our solar system. Since then, many, many planets have been found outside the solar system. So we know, I think when I was born, we thought, we are special. This is the only planets, there's only 9 planets in the universe. And our sun is special, and the earth is special. I think now we believe that most stars have planets. And probably there are many, many stars around the universe with a planet just like this. And maybe there are many classrooms around the universe where someone is standing having the same discussion as this. So that's something that's changed, I think. The Earth's population when I was born was 3.5 billion. It's now more than twice the population. Life expectancy in the UK was 72. In Japan was 71. So when I was born, people in the UK lived a little bit longer than people in Japan. Now people in both countries live much longer, and people in Japan live longer than people in the UK. Recently, in the UK, I think life expectancy has been going down a little, which is a bit alarming. And when I was born, homosexuality was a crime. People could be arrested, put in prison. And rather scarily, in Australia, the original people in Australia were not considered human until the year I was born, when they started to consider the original inhabitants of Australia as humans. Before that, they were not in the census. When they were counting how many people lived in Australia, they ignored the people who were there, the people who had been there for 40,000 years, which I find still quite shocking. Also, these were true when I was born. So carrots help you see in the dark, which most people of my age, in England at least, believe that carrots help you see in the dark. Now, the reason people believe this was propaganda in the Second World War. So during the Second World War, they invented radar. Radar is a way of seeing with radio waves. You can see when aeroplanes are flying from Germany and dropping bombs on cities in England. And in England, they worked out how radar works. So they could see the German planes flying to England, but it was a secret. So they didn't want to say that we have invented radar. So instead they made up a story. They said, we have our pilots are eating carrots, and carrots have vitamin D, maybe? Vitamin D. And vitamin D is very good for your eyes, and it helps you see in the dark. So the government told us that carrots help you see in the dark. And the government told people, I was born 20 years after the end of the war, and we still believed that carrots help you see in the dark. I think similarly, I've heard that in Japan, Japan was also fighting in the same war. Similar to the UK, there was the UK and Japan are both islands, and there's a limit sometimes to how much food can be imported, and food is very important during a war. And I've heard that because of the war, people in Japan had to eat more vegetables. And the government told people that Japanese people have a long intestine, so they're very good at eating vegetables, which is similar to in England. They told us carrots help you see in the dark. When I was born, Yugoslavia, Czechoslovakia, West Germany, South Vietnam, these were all countries. The Prime Minister was always a man. I think the first Prime Minister in the world was in about 1960. So that in, I think, Sri Lanka. I think Sri Lanka had a female Prime Minister from 1960. And I think India had a female Prime Minister in the 1960s. But at least, and in Japan is more recent. So that's changed. Also, I think they believed, around when I was born, they believed that women could not run marathons, that it would be dangerous, that women may die if they run marathons. And of course, this is complete nonsense. But at the time they stopped, there was a case in the Boston Marathon where a woman tried to run in the marathon and was chased, and they tried to drag her off the course. So, but of course, women can and probably always have been able to run marathons. And I think also they believed when I was born that human character was decided by the age of 3. So they thought that character was kind of fixed in very young babies, and then people don't change for the rest of their life, which I think now is not. This is so all of these things were true once upon a time, and they have changed. Further back, people believed that the Earth was the center of the universe. People believed that the Earth was created 6,031 years ago, with the animals and the plants in their current form, so that the Earth was created as it is, which I'll come on to in a moment. People believe that time is the same everywhere in the universe, which I'll also come into in a moment. And people believe that the continents, until the middle of the 20th century, people believed the continents were fixed. They then discovered that the continents are actually moving, and this is all more recent. There's an idea of half-life is used in radioactivity, and the half-life is when if you have a radioactive material, it's giving off radiation, and it will give off radiation forever, but gradually it will get weaker and weaker and weaker, and at some point half of the radiation is gone, and this is called a half-life. I think also facts tend to have half-lives. So things are not true forever. In mathematics, when something is true in mathematics, it is true. So 2 + 2 is 4, and 2 + 2 will always be 4. I think this will not change. In physics, when something is true in physics, it's usually true for hundreds of years, for quite a long time. In medicine, the truth in medicine seems to change more quickly. Some of the things that used to be good for you when we were younger are now not good for you. Some things that used to be bad for you. So, for example, smoking. People would say smoking is good for you. It makes you relaxed. Stress is bad for you. I think fat and sugar both have fat. For a long time, people thought fat was bad. I think fat is not bad, and sugar I think is bad. But before, people have thought that sugar is good. So, but these facts seem to change, and technology is changing even more quickly. So things that were true 5 years ago in technology may be no longer true today. And in politics, sometimes I say months. At the moment, it seems almost like weeks. The truth is changing rather quickly in politics. So there are different things are true for things generally are not true forever. And how long are they true for? This is how different scientists look at each other. So I think the mathematicians look at the physicists and think, well, physics is just applied mathematics. Mathematics is real science. The physicists are going and applying it. And the physicists, I think, look at the chemists and think that physics is real science. Chemistry is just applying the physics. And I think the chemists look at the biologists and think that chemistry is real science, biology is applied chemistry. And then psychology is just applied biology, and then politics maybe is applied. So there's a scale from hard science down to softer science. But what is science? This is the topic for today. What is science? We have a range of different sciences from biology, physics, chemistry, politics. Is politics a science? Anyway, so what is science? Is science a series of facts? Is it people in white coats with difficult equations? Is it good questions? Is it a model of the universe? Or is it a process for finding truth? In science we start with a hypothesis. Actually, we don't try to prove that it's correct. We try to prove that it's wrong. So we come up with an idea and we try to prove that our idea is wrong. And if we don't prove it's wrong, then we keep the idea. And this is quite important. So for example, here's a hypothesis: smoking causes cancer. So we try to prove that this is wrong. So for example, are there people who smoke who don't have cancer? And are there people who don't smoke who do have cancer? And in fact, we can find people who smoke who don't have cancer. We can find people who smoke who don't smoke who do have cancer. We can maybe also find other causes. So what other causes are there that may be causing cancer among smokers? And if we can find, once we find all this information, we can say this is not the reason, this is not the reason, this is not the reason, and we can eliminate the other reasons. And we can also look at statistics. So we can look at the numbers. What's the probability? I'll probably talk about smoking, not today, and maybe next week, next lesson I may talk more about smoking, because smoking is a very interesting in terms of science. If you smoke a cigarette, probably you won't die. Okay, so it's not like if I have an apple, and if I drop the apple, I know that the apple will fall to the ground. So whereas with smoking, it's not 100%. If you have one cigarette, you will die of cancer. But so there's a different thing which I will come on to later. So hypothesis. Science is a process for finding information. It's for finding out what we know. And also science, I think, works on models and reality. And let's talk about these two people. This is Newton on the left, and this is Einstein on the right. They both have, they're both very successful scientists. We still use Newton's ideas. We still use Einstein's ideas. And Newton's universe, time is universal. It's the same time everywhere. Space has 3 dimensions, and space is flat. And gravity, he had a theory for why we are not floating into space, why we go on the ground. And his theory was of gravity, and if there are 2 masses, they pull each other together. Einstein has a completely different idea. So for Einstein, time is not universal. The speed of light is universal. Space is not 3 dimensions. Space is 4 dimensions. So time is another dimension in space. And mass changes the shape of space. So space is not flat. Space can be curved, depending on the mass. And also time changes. Gravity will change time. And speed will change time. So there's just as an image of, on the left is Newton's universe, which is nice and flat. On the right is Einstein's universe, where you can see we have more gravity on the Earth, so that the space is kind of twisted by the Earth. So Einstein, he has a theory for why we go on the ground. And his theory was of gravity, so the speed of light is universal. The speed of light is not 3 dimensions. Space is 4 dimensions. So time is not 3 dimensions. Space is 4 dimensions. And mass changes the shape of space. So space is not flat. Space can be curved, depending on the mass. And also time changes the gravity will change time. And speed will change time. So there's just as an image of, on the left is Newton's universe, which is nice and flat. On the right is Einstein's universe, where you can see we have more gravity on the Earth, so that the space is kind of twisted by the Earth. Who cares? Why does this bother us? What use? So Einstein's ideas are called relativity. Why do we care about relativity? When Newton's science is, when they went to the moon, they calculated their journey to the moon and back using Newton's science. No problem. Newton's science works great. There are a couple of things. Mercury is the closest planet to the sun, and closer to the sun has lots of gravity. And there was a slight error in the orbit of Mercury around the sun, which scientists had measured, and Einstein's theories explain why Mercury's orbit is slightly different. Another thing that you may know is GPS. Do you know GPS? GPS. So GPS is global positioning system. On your phone, I'm sure you have GPS. Your phone can tell you exactly where you are on the planet. The way it does this is what's called triangulation. So if you know the distance and the direction to some fixed points, then you can work out where you are. Triangulation has been used for at least 100 years. It's been used for ships that would listen for a signal from radio. There are fixed radio beacons, and they can measure from the radio beacons where they are with the direction. The way it works on your phone is there are some satellites going around the Earth, and basically the satellites send out a time signal, and your phone picks up the time signal and measures how long it has taken for the message to get from the satellite to your phone. Now, one light nanosecond, a nanosecond is 1/1000th of a second. It's about 30 centimeters. So if you can count how many nanoseconds the signal takes, then you know the distance from the satellites. So if you know the distance from 2 satellites, you can work out your position on the Earth. This seems to work, I think, if you're not in a tunnel. What's interesting is the clocks are in the satellite they need a clock to send a time signal to the Earth. Now the satellites are 20,000 kilometers up in space, and they're moving to go around the world. They're moving at 14,000 kilometers per hour. So they're moving very quickly. Because they're higher up, the gravity is lower. Thanks to Einstein, we can find that there's less gravity. This makes time move more quickly. They're also moving at a higher speed. This makes the time move a little bit more slowly. So overall, it's about 38 microseconds. That's 38 millionths of a second slower every day. Now, for most of us, this is not a big problem. This is not a big problem. If my day is a microsecond longer or shorter, I'm not bothered. However, in this case, we're using the time to measure the distance, and 1 nanosecond is 30 centimeters. So 1 microsecond is 30 kilometers. So if we don't change the time, then every day our GPS will be 10 kilometers wrong. So this is an example of something that seems like this science is not connected to me at all. This is just some crazy mad scientist coming up with some stupid ideas that have no connection to the real world. But there is a very real connection to the real world. And not only this, but the hypothesis, if we take Einstein's theory as a hypothesis, every time you use your GPS, you are testing Einstein. So each time you're using your GPS and it works, that's proved that Einstein is not wrong. So this is kind of how science works. The lessons. So Einstein did not invent GPS. Einstein's science is also used in solar panels, I think. Einstein didn't invent solar panels, but his ideas in pure science have practical uses in the real world, which I think is an important lesson to learn about science. Science is very helpful, and it has uses that we don't imagine when the scientists are thinking of ideas. And another thing about science is never really finished. We have a theory, because we're trying to prove the theory wrong. One day, maybe someone will prove the theory wrong. As in the case of Newton, Einstein came along and said, hey, Newton is wrong. And so theories will last. So someday, maybe someone will come along and say, hey, Einstein was wrong. In fact, this is what's happening. And they may have a better theory than Einstein. For now, Einstein's theory is the best theory that we have. But we need to look at if someone has proven the theory wrong, then we don't use that theory. We need to find a different theory, the best one that we have. We look at the evidence that we have, and based on the evidence that we have, we need to choose the best idea that we have, the best theory that we have. And often there are some questions left with science. Not all the questions are answered. And we need to balance what do we know, which questions do we have answers, what facts do we have, and what's the best guess that we can make. And interestingly as well, there's a difference with publishing, with scientific publishing. If you read a science paper or a science journal, and if you read a newspaper, there's quite a different story. Scientific journals, scientific writing is supply-led. So the researchers want you to read what they have written. They're trying to get things published because they want this information to go out into the world. They want people to read this. They want people to test their scientific ideas. There's a process called peer review. So if you're trying to publish a scientific paper, other scientists will read it first, then it will go into the journal. Generally, they are cautious and they're conservative. Generally, they don't make risky suggestions or ideas. They're slow. They're very detailed. Scientific research may be many pages long. And on the other hand, newspapers are trying to sell newspapers. So they will write what you buy. If you buy it and read it, they will write it. Newspapers, there should be fact-checking. Hopefully someone in the newspaper has checked the information before it's published. Often they do this because they're worried that a lawyer will sue them. If they say something bad about a person, the person may say, "Hey, you said this about me. I'm going to sue you." So often the fact checking is not checking it's true; it's checking that legally it's safe. And often newspapers are sensational. So newspapers will try and write something that is exciting, that's interesting. And often they're simplified. So newspapers often write much shorter versions. They don't have all the information in the articles. So there's a big difference between what we read in science and what we read in newspapers. And there are more differences. Usually scientific journals are read by a few specialists, and uncertainty. So in a scientific paper, they will say, I don't know this. I'm not sure about this. This part may be wrong. And they will say that explicitly in a scientific paper. And scientific writing, science is a process, and each paper is a part of a conversation. So the paper is not its own, it's not a standalone, this is true. It's part of a long process, a long discussion. On the other hand, journalism, newspapers are read by the public, so it's aimed at anybody should be able to read newspaper articles. And generally, newspapers say, this is true. We have found, we know this. So they tend to have an assumption that what they're writing in the newspaper is true, which is the opposite of what's happening in journals. And sometimes newspapers are called the first draft of history. So what goes in a newspaper, I think it is trying to say this is what we know, this is everything we know. So there's a big difference between these different styles of publishing. Consensus is when everybody agrees, when most people agree, when almost everybody agrees. This is called consensus. And interestingly, when consensus happens in science, that's when people stop writing about a topic. When people stop asking the question, that means that the scientists know the answer. So if you're looking if you're trying to find what the consensus is, it's not really written in the scientific literature, because the scientists are trying to write about new questions, and they're trying to write about what they don't know, questions that there is no consensus, that they don't know the answer. And there may be, once there is consensus, the scientists move on to, first the question is this true? And when there's a general idea that it is true, nobody has found this is not true, the next question is, like, how does it work? Or what are the limits, the range of the truth? Or what new questions, now that we know this is true, I have another question, what about this? So science is working, science is a process, and it's not a simple process where people say, I have an idea, I'm right. That's something that scientists don't generally say. So if you're trying to find out what's happening, then it's very important to look. And we're now we're very lucky. We have the internet, and we have access to a huge amount of information. But as I showed you before, newspapers and scientific journals are different. The kind of writing is different. So when you're trying to find information, it's important to check what you are reading. Who wrote this? Who is this person? Is there a name? If you're reading something and there is no name, be suspicious. If you don't know who wrote it, then you don't know who to trust. If you do know the name, another question is who pays them? What is their job? Does their job change what they're going to write? So if you're reading about the best pair of running shoes in the world, maybe the person who is writing this makes running shoes. Maybe the person is an athlete and they're maybe paid by the company that makes the running shoes. So think about what is their job, and think about why people are writing, why have people written what they are writing. And do they have a bias? Do they have an agenda? Most people have a bias. Most people are not objective. They have opinions, they have beliefs, they're writing from an angle, or they have an agenda. They want something, they want an outcome. They want you to believe something. when is there a date as well? If you're looking at sources, when was it written? Where is their information from? Usually, it's a good sign if you're reading something, and they tell you where they've got their information. That's usually a good sign. You can find that for starters, they have not just written from their imagination, they've written from research, they've found information. And often there should be links, in good writing there should be links to show you where you can find original information or find more. So good luck. Uncertainty. Are there any scientific facts? Simple answer, no. There are not really scientific facts. There are theories, there are ideas. There's the best model that we have, and there are ideas that nobody has proven wrong yet. So basically that's what science, and the ideas in science that are probably not wrong. I think that's the best. I think that's the best we can do with science. We can some of the ideas are almost certainly not wrong. Is it true then? So Newton's laws. But so going back to Newton, Newton was wrong with his theory. However, his laws, as I said, people got to the moon and back using Newton's science. So his calculations work on the Earth. Most planets in the solar system, Newton's theories work perfectly. They're fine. As I said, Mercury, the closest planet to the Sun, they found a mistake in the orbit of Mercury around the Sun, and it's 1% of 1 degree every 100 years. And this mistake is explained by Einstein's science. Okay, so the difference between Einstein and Newton is 1% of 1 degree per 100 years. I'm sure you'll agree that's a very small difference. But it has been measured. This was measured by scientists. Scientists knew about this before Einstein, and they knew something was not quite right with their understanding of the universe, and Einstein showed what was happening. So here are some more scientific questions then. Is the Earth getting warmer? Is carbon dioxide causing the climate to change? And kind of connecting these two ideas, is the Earth getting warmer because of human activity? So these are the scientific questions, and let's look at this. Let's look at Lake Suwa. So as I'm sure you know about Lake Suwa. This is Omiwatari, which I'm sure you've probably seen Omiwatari. And Omiwatari is a natural phenomenon. Very interesting. This has happened, I think, 7 times so far this century. So in the last 25 years, it's happened 7 times. What this means is it did not happen 18 times in the last 20 years. Now, Omiwatari, Lake Suwa, is very interesting. There's a very, very long record of Omiwatari on Lake Suwa. And I think it's the oldest record in the world of temperature. Because this happens when the ice freezes, and when it gets colder, ice expands, and so the ice will make a ridge. So this is a measurement of temperature. So this happens when it gets colder, and this has formed. So this did not form, and the records go back hundreds of years. There are hundreds of years of records. Every year, the priests would write down the date when Omiwatari happened. And so it didn't happen 18 times in the last 25 years. In the 50 years before that, between 1950 and 1999, it didn't happen 9 times. So this is twice as long and half as many times. So it's happening less often. It's happening less this century. It's happening much less than the last century. And we can go back along the record between 1443 and 1700, which is 257 years. It didn't happen 3 times. So this used to be every year. This used to be a very regular event every year. That in these, in maybe 3, so there were 3 freak years when there was no Omiwatari. In the 20th century, it's happening less, and I suspect if things carry on, I suspect it will become a freak occurrence when the Omiwatari does happen. So it's going from something that happened every year, pretty much every year, to something that maybe our grandchildren will never see Omiwatari. Maybe the data was very reliable over this period. There's a couple of gaps in the data, and this is the day, the ice freeze day of the year. So which day of the year the ice froze. So we can see there is actually a trend here where it's getting a bit later, but here the trend is very, very steep. There's a river in Finland somewhere which has a similar record where they've recorded when the river freezes or when the river melts, maybe. So there's a similar, and that also goes back a few hundred years. And there's another long-term record that we have of temperature. This is some of the written up temperatures. So this is a calculation of the average temperature. The temperature since around 1900, they've been measuring the temperature every year. These older figures are estimated based on when the lake froze. So we can see there's some fluctuation, there's some change in temperature. There is some change in temperature, but we can see here that the temperature is going up quite rapidly and quite alarmingly. So, my question, is this proof, does this prove that the Earth is getting warmer? Yes or no? Why or why not? So what do you think? Is this proof? Does this prove the Earth's getting, yes? No? Yes? I think this doesn't prove, I don't think this proves that the Earth is getting warmer. It's evidence, it's definitely evidence, but evidence is not proof. So maybe this is wrong. What I'd like to do is think about, let's imagine the Earth is not getting warmer. The Earth is not getting warmer, but why could this be happening? Can you try and think of another reason why this is happening that is not because the Earth is getting warmer? Please come up with some ideas, come up with some alternative possibilities. So maybe there's a long-term cycle, every 100 years or 200 years, the temperature goes up and then goes down. So it may be part of that's one possibility. The Earth's not getting warmer, it's just a cycle, and we're now at the top of the cycle, and then later we'll go down. So that is possible. It's possible. Other ideas, please. What other ideas? Can you think of other ideas to explain the facts? You've been to Lake Suwa. Have you been to Lake Suwa? You've been to Lake Suwa. Have you been to Have you been to Lake Suwa? Yes. So think about Lake Suwa. What else might be happening? Yeah, it could be a measurement problem. Yeah, possible. Any other ideas? Oh, water pollution. Yeah, yes. So there's stops freezing. Yeah. Like you have antifreeze. Maybe somebody who's Epsom. Epsom is next to this. Oh, Missile. Oh, it could be Missile. Yeah. Sorry, yeah, not Epsom. So yes, that's possible. Any other possible explanations? There are various reasons why this may be happening. There are hot springs around Lake Suwa. Maybe there's more water. Hot spring water is going into Lake Suwa and it's being kept warm by the onsen. Maybe possible. As you said, chemicals change the freezing temperature. That's possible. There may be some local climate effect in the Suwa. So it may be that it's getting warmer in Suwa, but that doesn't necessarily mean the whole world is getting warmer. It may just be a local climate issue. Heat island effect. I think probably there is more concrete now around Lake Suwa than there used to be in 1440. So maybe that's affected the temperatures being held by the concrete. There may be some natural variation, or as you mentioned, it may be like a long-term cycle that we're on this part of a long-term cycle. As far as natural variation, the scientists have done this. Will go through all of these other possible explanations and try and see if these are possible. See if there is more chemical pollution, if that makes a difference. See if there is a local climate effect. See if there's a heat island effect. So the scientists will look at these other explanations and see if they affect, which I don't think they do. As far as natural variation, it's possible there is some natural variation. This is a two-headed coin. If you flip a coin, usually there's 50% chance of heads, 50% chance of tails. Now, if you have a two-headed coin, there's 100% chance of heads and 0% chance of tails. And if you want to know if the coin is a two-headed coin or a normal coin, if you flip it once, there's a 50-50. If you flip the coin twice, there's a 1 in 4 chance that it's a normal coin. If you flip it 3 times, there's a 1 in 8 chance, and so on and so on. If you flip the coin 100 times, and every time it's heads, there's a very, very small chance that this is a normal. It's not impossible, but it's very, very unlikely. So in science, we often use this approach where we look at the statistics. Maybe this is random, and we can calculate what is the chance of this data happening at random. So we can calculate the chance of 18 years where there is no ice forming. And if we look back at when there was ice forming every year except 3 years, then we can see the chance is very small that this is just a random event. So truth. I think there are different kinds of truth. I think probably we would agree that these are all true, but I think we can see, please discuss, I think we can see these are it's a different kind of truth. When we say you should not kill people, is not the same kind of truth as 120 million people live in Japan, I think. Please discuss what's going on here. So I think we can see that there are moral, ethical truths. You should not kill. This is not scientific. There are empirical, so there are things that we've measured. There are facts that we've measured. there are statistics, so a probability. There is predictive, so there are some things that are true about the future, where we can make a claim about the future that we can say is true. And there are some scientific things that are scientifically true, or that we consider to be true. And if we look at religion, so if we look at three different areas, religion and law and science, they have very different. The truth is important for all of these things. In religion, especially within Christianity, there is no proof. You must have faith. You have to believe, and that's the central idea, I think, in Christianity. Legally, people are trying to prove that I'm right and that you're wrong, is the usual basis in law. And within science, scientists are trying to prove that they are wrong. So there's quite a different idea of what truth is. Just follow the money. This is an American dollar bill, and as you may notice in the middle, it's in God we trust. This is the religious story. I'll try and do this very briefly. The religious story is quite long. So in the religious story, God created the earth. The world began on the 23rd of October, 4004 BC. And Newton, you will know Newton as a scientist. Newton was also very religious. And at the time, they believed that the Bible was true, and spent a lot of time working out from the Bible the date, working out the timeline from the Bible. And they got back to the beginning of the universe was on 23rd of October, 4004 BC. And this was something that Newton spent a lot of his time working through the Bible and calculating the life of the Bible. And this used to be written in the King James's Bible. In the margin, the dates were added for people's reference. The Bible says on the first day God created heaven and earth. On the second day he made the skies and the seas. On the third day he made land and plants. On the fourth day he made the sun and the moon and the stars. On the fifth day he made whales, animals of the sea and of the air. On the sixth day he made beasts, cattle, creepy things, and men and man. And then he was very tired and had a day off on Sunday. So this is what it says in the Bible. And people believe this to be literally true. They believe that the world was made in 7 days. And some people still believe this is true. Another thing that it says at the beginning, this is the first page of the Bible. And it also says, let man have dominion over fish, fowl, cattle, over all the earth, and over every creeping thing that creepeth upon the earth. So also it says that everything on the earth is for us. Everything is there for us and belongs to us. So the idea, so you'll notice that the sun, the earth comes first, and then the sun and the moon were made later, which is not necessarily the same as science. So Copernicus, this is Copernicus, who thought, well, wait a minute, I think the earth is not the center of the universe. I think the sun is the center of the universe, and the earth revolves around the sun. Now, before Copernicus, he waited till he was a bit scared of publishing this, because he realized what he was saying was different to the Bible. And so he waited until, I think, just before he died, he published this paper. So this is Copernicus's model of the solar system. There was a model of the solar system because they knew they could see the planets, they could see the moon, but this is a lot more complicated. If you make a model of the solar system where the Earth is the center, the planets are doing quite strange movements and not a simple system as we have, where the sun is the centre. Copernicus was saying this in 1540. Galileo, who you may have heard of, he had a telescope, so he could start seeing the moons on other planets. So he could see that Jupiter has moons revolving around Jupiter, which he thought was strange when you're comparing it to the Bible. And so he started. He published about this. This is long after Copernicus had died, and he got into big trouble for writing something different to what was written in the Bible. He was told that he must recant. He must say that this is not true. He had to go to prison, and his book was banned. Until the church did react to this science, but it took about 100 years before the Pope allowed his works to be published. It took 100 years after he died, until 1740. The church allowed people to believe that the sun was the centre of the solar system in 1750. In 1992, the Pope said that he was sorry about what happened to Galileo. This is already 100 years. This is like 350 years late that the church finally comes out. A similar thing could have happened with these are finches that a guy called Darwin, who you may also have heard of. Darwin, he came up with a similarly anti-Christian idea, or an idea that does not meet with what's written in the Bible. And his idea was that the theory of natural selection, the origin of the species. So his idea was not that God had made all the creatures as they are, but his idea was that the creatures have evolved from other creatures and go back to the same life. And just like Copernicus, he wrote this, gave it to his wife, and said, "When I die, please publish this." And I think it would have not been published, except there was another. There's a picture of Darwin. There's another. So when you what happens? There's the science and what's written in the Bible. So scientific research and belief, and when these don't meet, then there are three things you can believe. You can believe that the Bible is wrong, which is dangerous in a Christian world. You can believe that the science is wrong, or you can believe that the Bible is not literal. The Bible is a story, and it's not what it says is not literally true, but it's a story. Which doesn't mean that the Bible is completely wrong. But it means the Bible is not science. Science is science, and religion is religion. Darwin. So the issues. There are issues in here that we can see. I mean, for a start, whales in the Bible, whales appear before cattle, and in fact, in evolution, whales come from cattle. So the order is a little bit wrong. Plants did not become before the sun. I think there's a few issues with the order, but plants did become before animals. So some things maybe it's not great. It's not very scientific. The reason Darwin published was because there was another young scientist called Alfred Wallace, who had the same idea and had started writing and was about to publish his idea. And so Darwin thought, well, if he's going to publish, this is my idea too. I don't want him to steal my idea. And I think they came to the idea independently. They came separately. So Darwin did publish, Interestingly, also on the subject of science, Darwin also thought about the age of life. Darwin he studied animals, he studied plants, he studied birds. He also studied geology. So he looked at the earth and different rocks and different soils. And based on the geology and also looking at the evolution, so looking at how many different kinds of animals there were and how long it takes for animals to change, he estimated about life on Earth was about 300 million years old, which is quite accurate. This is quite close to what we believe now. At the time, Lord Kelvin, who we met last week, and the physicists, they believed that the Earth was only about 20 or 40 million years old. So this is about Darwin's estimate was about 10 times longer than Lord Kelvin's estimate. He was basing this on thermodynamics, so how hot he thought the Earth was, this ball of liquid that had gradually frozen. And based on the temperature and the time, he also believed that the sun, I think the physicists believed the sun was just burning hydrogen. They didn't know about nuclear physics. So in fact, the sun is a nuclear reactor where hydrogen is joining together to make helium. And they didn't know that. So based on the physics at the time, they thought the solar system, they thought the Earth was much younger than it is. But Darwin thought that he was wrong and that the physicists must be right. So he trusted the other scientists, and he did not publish this because he was not sure. So this is a measure of how conservative science is. Scientists generally don't say things unless they are very sure what they're saying, and they do tend to say, if they're not sure, they will say that they're not sure. So that's so in the case, luckily for Darwin, the science was accepted very quickly within 10 years, and there are still some debates about exactly how it happened. DNA was not discovered, so the mechanism of evolution, the genetics, was not discovered until later. And the church was a little bit quicker in the case of Darwin, but it still took until about 1950. It still took several years before the church agreed that evolution was not forbidden. And it was accepted in the 1990s as more than a hypothesis. So the church is starting to say that evolution is probably happening. However, there are still ideas. The idea of creationism. There was a movement from the 70s not among the Catholic Church, but among other churches, to go back to the Bible as it is written in the Bible, and to try and push the idea of creationism as a science, and to try to get science lessons to teach that the earth was made in 7 days by God. In science lessons, which there is something, there is a quite, go and read about this if you're interested. Today we have run out of time. I'll just leave you. Let me just leave you with a few everyday ideas about science. So when you, as I said before, each time you use GPS, each time you make a cup of tea, you're doing science. When you cook, you're also doing science. Every time you see a plane flying in the sky, this is science. And each time the Wi-Fi works, So every time you use GPS, as I said, you're testing relativity and the different gravity and speed. Every time you drink a cup of tea and notice that the tea is getting colder and not hotter, you're testing the second law of thermodynamics. Every time you cook, there are lots of chemistry experiments that are happening in your cooking. Whenever you see a plane flying, this is testing fluid dynamics. So there's a lot of science happening, and every day we're testing when the planes don't fall from the sky. This is showing that the science is still working. And Wi-Fi relies on quantum physics, which I don't understand quantum physics, but when we're using Wi-Fi, that shows that it's working. Good luck. That's all. What to do? Saying that you don't know is not a bad thing, and saying I don't know is the first step for science. Is about saying you don't know and understanding what you don't know and trying to find the answer or finding possible answers. I think that's all. Just lessons to learn. So models. So all models are probably wrong, but some models are useful. So some of the scientific models we have will help us to understand the universe. Science changes. It's not fixed. And pure science does have practical uses in the real world. I think that's all for today. Thank you very much.